Hello everyone. In this video, I would like to introduce the enhanced Linux container technology called LXD. Right? So first we will introduce what is LXD and its architecture. Then we will make a brief comparison between LXC and LXD. Right? Then we will talk about the LXD containers. Uh, Basically, it's based on LXC. However, there are some enhancements. Right? Then we will talk about the image, LXD image, and its root file system. Right? Then we will demonstrate how to initialize the LXD environment, and in the next video we will start using this environment to set up our containers. Okay, so first, what is LXD? LXD, right here, if you would like, you may follow the link to the official website, and there are technical documents and some community links. In short, LXD stands for Linux Container Daemon. Okay, so given the daemon, that means it's a kind of service in the Linux system. Many people just pronounce LXD as LXD, okay, LXD, and it serves as a daemon providing the REST API, right, to manage and operate LXC containers. So from this description, you can imagine that LXD is just a piece of software, and it's used for managing LXC containers. Okay? And this piece of software provides the network, or maybe the socket. Okay, not necessarily the network. Basically, it's a socket communication endpoint, and it provides the protocol using REST API. Okay, so you may follow the syntax and issue some commands to LXD for managing the containers. So LXD, right, builds on top of LXC, enhancing it with a more user-friendly experiences. Basically, LXD is a high level. Right? Just consider we've already practiced many LXC related operations, and you could see that we need to manage a lot of low-level details like the bridges, the IP addresses, or even some whether it should be auto start, and almost everything are done via editing the configuration file. And you need to be careful about the configuration file syntax and the proper values. In LXD, you can just consider there is a manager. So the manager can memorize the configurations. What you need to do is to issue a command to tell the manager what kind of configuration you would like to set, and the manager will verify the request, and if there's any error, it reports the error to you. Right? So you don't need to actually even you send a wrong configuration, probably the daemon, right, can report the error while parsing the request. So it was originally developed in 2014. Right? It aims for offering the features typically expected from a virtual machine hypervisor, but using a lightweight Linux container instead. So at that time, virtual machines are pretty popular. However, virtual machine is heavyweight. we emulate from the hardware level. Then container is already proved that it's working for LXC. Okay, and LXD project was initiated and try to adapt some operation style for virtual machines to the containers. Right? So that's easier for the administrators. Okay? They have already familiar with how to manage a virtual machine. Then if the command line or the concepts and architectures are similar, right, the high level interface is similar, right, to managing the virtual machines, then it's easier for the administrators to migrate their solution, right, to the container based solution. And we've already explained that in many application runtime environments, actually we don't need the emulation to the hardware level. What we need to have is at the operating system level, the runtime, software runtime level. So containers is very important for this purpose. So LXD, you could see that the low level hardware infrastructure, and then the host kernel, and then host OS and LXC environment. And LXD is an additional piece of software. So we can, for example, from the host OS, we can send the command to LXD, and LXD utilizes the LXC mechanism to start the system containers. And here is the point. LXD operates on a client-server architecture where the LXD daemon acts as a server managing container instance. Then we will later we will see that we just use the main command called LXC, and then there are different subcommands for this context. So allowing user to interact with the daemon effectively. LXD provides REST API enabling remote management. So in addition to issuing the request directly from the host OS, if you configure your LXD, listening on the network interface, you can issue the command to LXD via the network endpoints. The architecture is built on top of LXC library, leveraging its feature for container management and isolation. And please note that for LXD, it's basically the system container. And if you later, if you review the related document, you will see that there's no way to use LXD to start an application container. Basically, LXD is used for a system container. Just consider its origin. It was designed to help the administrators to migrate their virtual machine experiences to the container-based architecture. So they just focus on system containers. Let's compare the commands in LXC and LXD. So in LXC, when we would like to create the fundamental environment for a container, we say we create based on the given template. Okay, so for example, we use the Ubuntu template for preparing the root file system for this container. In LXD, okay, the corresponding command is LXC launch. Okay, launch. The launch is not start. Okay, launch is just consider it's just preparing for the runtime. So we download the necessary files, and later we will see that basically the necessary files includes the so-called images, okay, the fundamental images, and preparing some additional spaces, okay, for runtime, read and write. So we launch, okay, given the image name. Okay, here is the image name and then the container name. So this by this one we create, okay, the necessary files and file systems for running the container. To start, okay, LXC start, and here LXC start. Okay. If you would like to attach to the console in LXC, we just use LXC attach. In LXD, okay, we don't have a direct command for attaching to the terminal. What we should do is to execute a shell. Okay, execute a shell. So here we use LXC exec given the container name and the shell name. Here in LXC it's different. In LXC, when the container is running, okay, we use LXC attach, okay, and we will be dropped into a root shell. Okay. So it's at runtime when the container is running, we use LXC attach. When the container is stopped, and we can use LXC execute to start or to launch a specific program, okay, as the running process. However, in LXD, we don't, since it does not support the application container, so basically there is no corresponding LXC execute. What we have is something similar to LXC attach, and the name is LXC exec. So don't be confused, okay, with LXC execute and LXC exec. Okay, they are different. Okay, if you insist to find something equivalent, we say, okay, the LXD in the LXD command LXC exec is roughly the same, okay, as the LXC attach. Okay. However, that's only for the case, okay, executing the shell. Okay. Okay, so for the feature comparison, in LXC, okay, we have only the basic security features. If you would like to get some enhanced security features, you need to configure, carefully configure the LXC. In LXD, some of the not really advanced, just enhanced security features are enabled by default. For example, unprivileged container. In LXC, we can start LXC as a regular user. Okay, it's called unprivileged container. However, as we demonstrated we always use sudo, right? Because in LXC, unprivileged container is not pre-configured by default. Right? If you would like to use unprivileged container, you need to install some additional packages, especially for the ID mapping, ID map uh, package for mapping the regular user ID, right, to the root ID inside the container, and you need to configure that. So in LXC, this feature is not enabled by default. Right? For LXD, it's enabled by default because when we use unprivileged container, if the container has some security flaw and someone get the root privilege, it's still limited, right, in the regular user ID from the viewpoint of the host, right, from the viewpoint of the host, right? So it's isolated, right? The root is simply the root of the container, and it is mapped to a specific user in the host system, right? However, if you use privileged container, suppose someone get the container's root, basically it has the privilege, right, of the host operating system root. The only difference is that namespace, right? If the namespace, the container is namespace guarded, but it is possible to change that and break the namespace barrier if the user get the root privilege. Right? So this is the security issue. The next one is about the management. So LXC requires direct management. So we only have the host side utility for managing the LXC containers. For LXD, in addition to the direct management, we can also use API-based management, so it's more flexible, especially when you have a cluster of computers. Maybe you are running a data center and there are a lot of containers distributed on different nodes. That remote management is very important. Interface. LXC has a low-level complex interface, and LXD simplifies the user experience, right? Because many details are handled by the daemon software. Networking. LXC support basic networking setup. Right? We've learned how to create a bridge, how to attach a virtual Ethernet to the bridge, and so forth. So while LXD offers advanced networking options including bridges and tunnels, right? So there are high-level commands for easily creating a bridge dedicated for a few containers. Right? Storage. LXD provides simple storage management, right? And of course, you can use some more complicated storages types. However, you need to manually configure that. And in LXD, it supports more kinds of storage backends, okay, like the high-level LVM or ZFS. Okay, then for LXC, we just use templates for image deployment. So basically, we copy, right, the necessary files according to the template, and that's dedicated for the container. In LXD, later we will learn that it is based on the concept of image. So there is a shareable layer of files, right? So when we need to create multiple instances based on, say, for the same version of operating system, okay, we don't need to copy the files, okay, to the individual containers. Okay. Most of the files are shareable, and then for each container we will have a specific dedicated storage space for copy on write. Okay. So in LXD, of course, we have the containers and images. Images serve as a template for creating containers, typically based on clean Linux distribution. And please note that image is the shareable part. So once the image is downloaded later in LXD, the image is considered as read-only. Okay? An image is read-only. Okay? Then we use overlay concept, okay, to prepare a read-write layer on top of the image. Profiles in LXD allow user to define reusable configurations for containers. So sometimes we would like to define, okay, some configurations, okay, like the number of CPU cores allocated that can be allocated to the container, or the maximum size of memory that the container can use. Okay, these are configurable, and maybe we would like to apply the same configuration to many created containers. So in LXC we need to edit the config files again and again, okay, because there's no configuration management mechanism. In LXD, okay, we can define some properties for a container in the so-called profile, then later create the container based on the given profile. Storage protocol. Okay, LXD uses storage pools. Okay, storage pools. So it is a high level concept that we can collect available storage spaces as a pool. Then each container can allocate the necessary size of storage space from the pool. So it's a kind of virtualization. Remember, in the virtualization concept, this is the storage virtualization. And networks. LXD provide networking options to containers, right? And security issues. All right, we've talked about that. So LXD, right, it's basically a system container manager, designed to be a system container manager, and it runs a full Linux operating system, right? And similar to a virtual machine, ideal for long-running applications. And key component, we have the root file system, okay? And the root file system is basically a composition of the read-only image layer and the read-write enabled overlay layer. Configuration options, okay? Devices, the virtual devices, okay? Disks or network interfaces, and profiles. Then for container properties, there could be the runtime lifecycle state, lifecycle state, like it is running or it is stopped, right? Or in LXD you can also use snapshot, right? So in LXD image, when you need to access an image, right, in LXD there is a repository for collecting the images. And here is an example. This is just a convention. Okay, in the default image server, suppose we access an operating system image Ubuntu colon. This is for stable images, stable version, and Ubuntu dash daily. Right, this is for daily builds. Right. And if the image, right, has a name like images colon, this is usually for community contributed images. Then images will be locally cached, right, because it's read-only and it's shareable. So LXD, right, just catch the downloaded files or downloaded images, right, so that later we don't need to repeat the download process. Right. Automatic update. Please note that automatic update does not mean the update for the running container. Right. For here, automatic update means once we say we have a cached version of Ubuntu system, if the image has a newer release, right, maybe a bug fix or something, LXD will periodically check for this and download the updated version. Right? And for the updated version, it only affects, right, the containers launched, right, after the download. Right? After the download, if it is already based on an older version, to make the system consistent, we cannot directly update the base or the image, the read-only image, right? Because it breaks the consistency. Right? Then custom image publishing, it allows you to customize your image. However, we just know about this, and later I think we will get a more solid concept about custom image building and publishing when we learn the Docker related technology. Okay, so image and rootfs. Image is the read-only layer, right, for the file system, and rootfs is the storage space for a container. So it's a copy of the image, and then on top of it there is a rewrite enabled layer. Right? So this slide shows some points, okay, whether you need to use LXD or LXC. Personally, I prefer LXC, right, because LXD, we have an additional piece of software, and it is a daemon running in the background. So unless you have a lot of container to use, right, if just for personal use, I think LXC is enough. Right? If you are managing a data cluster, maybe you need to learn LXD, right, because you need remote administrations and you need to manage the containers remotely. Right? So LXD is more has more features for this purpose. Okay, so it's time for installing the LXD, and before we issue the command, let's see. Installing the LXD, basically you can install from snap or using apt or build from source. So the suggested way is to install via snap, and in Ubuntu, if you type the command LXC, the first time you type LXC, okay, LXD will be installed, okay, before, okay, the command is ready. Okay. So there is a stop command, also called LXC, okay, in the system, in the Ubuntu system. So I think let's do the demo. Okay, so let's see. Here is our system, and sudo snap install LXD. Oh, already installed. Maybe let me uninstall it. Sorry. Okay, so LXD is now installed, and let's see the next initializing. Okay, so we need to initialize the LXD. Okay, and during the initialization, we will be prompted to configure the storage backend such as dir. Okay, the plain directory, btrfs. Okay, it's a file system and contains many modern features. ZFS is also a powerful file system, or LVM for large volume management. Okay. Later, I will use dir. Okay. And you will also set up networking by configuring the bridge. So this, you may consider installing the default bridge LXD BR0, and the init process allow for additional configurations. So let's see. Okay, so now sudo lx so lxd init. Okay, would you like to use LXD clustering? Currently, no. And do you want to configure a new storage pool? Yes. And the new storage pool. Okay, let's just choose the default. Name of the storage backend, okay, to use. Okay, pure btrfs ceph dir lvm power flex, and the default is btrfs. Maybe, okay, let me insist using the dir. And would you like to connect okay, no. And would you like to create a new local network bridge? Okay, yes. And use the default LXD BR0. What IP address should you use? Sitter subnet notation, auto, or none? Okay, let's just let it pick. So auto. And what IPv6? Auto. Would you like the LXD server to be available over the network? Unless you know that you really need remote administrator, for security concern, it's better to choose no. would you like store cached images to be updated automatically? Okay, use the default yes. And would you like YAML LXD init preceded to be printed? Okay, no. Okay, now let's see IP link. You could see LXD BR0 is here, and IP ADDR. Okay, the default IP address 10.150.9.1. Okay, so it is already configured. Okay, so now let's see the next, some properties, okay, about the LXD. So here are the 3 commands you may try: LXD info, LXD image list, and LXD network list. Okay, so let's try. Maybe LXD info. Okay, so this is the you can see that there are, okay, this is a very long list, okay, of output. So this is a configuration about API extensions, and let's scroll down, API status, API version, and then the certificate. Okay, and for the firewall, okay, it uses the NetFilter tables, kernel Linux, architecture, Intel architecture, kernel feature, and LXC feature, C group enabled, and so forth. Server, LXD, storage, the type is dir, and storage supported drivers, it supports dir, LVM, and so forth. So this is about the LXD, and how, let's see, network list, so you can see that for LXD, the network, we have the LXD BR0 here, and the related network, this is the network interface at the host. Then image list, no, and let's consider like the example, no, maybe a Ubuntu. So this is a way to help you list the available Ubuntu images in the image repository. So you may consider using later. You may consider downloading the specific Ubuntu version. And please note that there are different architectures. Okay. Now let's back. So this is about using the image list. Then it's about time for you to do the practice, okay? Similar to what I have demonstrated. Okay? Install LXD, initialize LXD, and then try to browse various kind of configurations. Okay, so here you may encounter some issues and try to, there are different ways for resolving the issues, and it requires the knowledge for Linux host, usually at the Linux host side. So for example, how to access the system journal or the system log, and how to examine whether the storage space is large enough, or how many free spaces in your system. You may use DU and DF to check. And network, how to identify the network properties. Maybe you just use IP command to check the links, addresses, or even some other like bridges, routing. Okay, so this is the first part about introducing LXD, and also the LXD initialization.